Hello. Welcome to episode 16 of Learning Golang from Zero. My name is Paul Kernfeld, and I'm a member of the technical staff here at Cockroach Labs. Today on this stream, what I'd like to do is cover this document, Effective Go. It's part of the official Golang documentation ecosystem. And this is kind of like after you already kind of know how to write a program in Go, best practices to help you avoid mistakes, write code that's, that other people can easily read, and code that just looks professional. So the reason that I chose to do this is because I thought that I think that it's actually really revealing of what are the strengths and weaknesses of Go. For example, if the effective Go docs contain an example of something not to do, I think that that's interesting because it's like it tells you that the language is letting people do something that then needs to be enforced at this sort of higher level of kind of like a social constraint. Another reason that I think a document like Effective Go is really interesting to look at is when you're kind of reviewing somebody's code and just kind of seeing, do they seem to know the language? I think this type of tip is often really, I think it's often used as a way to differentiate, like, does this person seem like they know Go at a professional level? So I think it really helps with like the kind of the smell of your code. Another reason I thought this might be good for a stream is because it's bite size. So you can kind of tune in when you want, tune out when you want. It might be content for just kind of popping in and out because it's a bunch of these I don't know, dozens or maybe even hundreds of individual tips. So that's kind of why I chose that. And then, I just kind of, also to get started, I wanted to show you guys the iced latte that I made for myself this morning. Oh, let's get that on camera. Ooh. Yeah, that's looking pretty good. We've just got some espresso and simple syrup on the bottom, a lot of crushed ice, and then a layer of milk on top to give that kind of effect. Takumi asks, what is your favorite language to begin with? That's a great question. I don't know that I have a recommendation on that. I personally started programming using a Texas Instruments TI-83 graphing calculator. It's powered by 4 AAA batteries, and it actually lasts like months before recharging it, and a truly amazing device. They have a language called TI Basic that I originally learned on, but I don't know, a good language to begin with. If I had to, I think it depends what you're interested in. I think JavaScript would be a fun language to begin with right now because you can start building interactive applications. The JavaScript ecosystem is massive, but you could certainly begin with a lot of other languages. I think that you could begin programming with Golang easily. And I'd love to hear if somebody, if Golang is your first language, like how does that influence how you think about programming? I don't think I've met someone who learned Go as their first language yet, but I'm sure there are plenty of people out there. Ooh, yeah, that latte is pretty good. I put in a lot of sugar, so that's why it tastes good. Yum. So pretty soon, I think we'll jump in. But yeah, curious if anyone had any fun updates this week. My my life update. I have like a little container garden outside, and there's one strawberry in it that's almost ready to eat. So I'm basically like a farmer now. It's about this long, but it looks really yummy. So I guess that would be the first. That's the first fruit that I've ever grown. Um, so I'm pretty excited to eat my lone strawberry. I also have like a bunch of herbs, like a lot of basil. Maybe make some pesto pretty soon. But yeah, now that the weather is getting hot, the herbs are really taking off. So that's kind of where I'm at. But yeah, let's jump into effective Go. I'll probably skip the more paragraphy parts. Go isn't. Maybe I'll just try and like summarize them a little bit, but you don't want me to read the paragraph verbatim because I don't have like a satisfying like British accent. That could be actually a good stream. Yeah, so you got to understand Go's peculiarities or its idiosyncrasies or its uniqueness in order to program well. I think that's true for every language. So with Go, they take an unusual approach and let the machine take care of most formatting issues. I really hope that most programming languages will do this in the future. I don't think there's much benefit in allowing ambiguity or opinion in how to format a program. I think that's something that the computer should just take care of. And both Golang and Rustlang do great jobs of this. You don't really spend too much time thinking about how to format your program. You just run Go format on your code and, boom, you're done. And the way that I do this for production code at Cockroach is that I actually have my IDE, which is Goland, set up to automatically format the file on save. I think that's a pretty common thing. It's not magic, but it's really satisfying. Like you type this thing into the IDE and then you like save it and it just like beautifully aligns all of your fields. So I'm a big fan of Go format. And I personally would recommend using a formatter in any programming language. I think it's always a nice thing to have that consistency. And just like, for me, it's like anything the computer can take care of that I don't have to think about, that's a bonus. Go has no line length limit. I actually didn't know that. Maybe I think at Cockroach we have like our own like forked version of Go format, and I think it does have a line length limit. Okay. Yeah, let's look at these comments. C-style block comments and / line comments. Great. Cool. Every package should have a package comment. Sora says, this has come back to bite me when I accidentally saved a minified JS file and my IDE was unresponsive for 30 seconds. That's an interesting point. So it was essentially taking, so the JS file, like you're saying the input is like one incredibly long line, and then it's trying to like reformat that into a file that actually looks good. Yeah, that seems a little annoying. Ideally, you would want it to happen like somehow in the background so it doesn't freeze your IDE. But you also don't want to let the user edit that file while the formatter is also trying to edit it. That's a little of a weird situation, yeah. Okay. So put a package comment that explains what your package does. That's nice. I like that. Use complete sentences. Oh yeah, and one thing that's interesting in Go that I think other languages have similar things is when you're writing the docs for a function, like since the function is named compile, you always include compile as the first word of the doc string, and that way it works better with the go doc subcommand. And I've definitely forgotten to do this sometimes. I bet you can make a lint for it though. I don't really use go doc, but I think I like if use it from like within my IDE. Ah, okay. This thing is nice. I like that you can just declare these multiple variables. I think this syntax just looks very satisfying to me. Oh, yeah. Yeah, that's good. Maybe this will explain something that we talked about on a previous stream, which is why do you need quotes around the import, but then when you declare the name of the package, you actually don't need to put quotes. I think the best theory was that so that you can't put weird punctuation into your package names. This is interesting. Some of this stuff I was expecting this to be more like examples of like write your code like this, not like that. But this is actually some more like high level. There's a lot more like prose in here than I'd expected. It's neither idiomatic nor necessary to put get into the getter's name. So if you have a field called owner, the getter method should be called owner, not get owner. Okay, that's the kind of advice that I was expecting. Like just some really like super concise and specific. I like that. By convention, interfaces are named with an suffix, reader, writer, formatter. Yeah, cool. And that's specifically for single method interfaces. So the reader interface has a read method. Yeah, sure, why not? Seems good. Okay, and so for Go we use mixed caps rather than underscores for multi-word names. Semicolons. Oh, interesting. So Go has like an automatic semicolon inserter that reminds me of the way that JavaScript works. I think where it will automatically, or at least older versions of JavaScript used to automatically insert semicolons where they were needed. Oh, this is interesting. I didn't actually know about this semicolon rule. If the last token before a new line is an identifier, a literal or one of these tokens, then you get a free semicolon. Okay. I think it'd be easier to see this with examples. But I think it's trying to guess like what is a statement basically. All right, let's see. So you do put semicolons in for loops. And if you want to write multiple statements on a line, I'm not sure why I would. Oh, I actually have seen. I've seen multiple statements within like an if clause, but besides that, I can't think of too many other places where I would write intentionally multiple statements on a line. So, oh my, this is a subtle gotcha that never would have occurred to me. I don't think it would have ever I wouldn't have ever thought to write code like this, so I don't know if I would have hit it. But if I did write code like this, I think it would be really confusing. What I think is happening is that this going to execute is this like braces going to actually execute unconditionally? Is that what's going on? I think I'd like to put this into the, maybe I'll just go to the Golang playground and paste this in. So yeah, curious what people think is going to happen here. What I'm going to do is I'm going to make a if statement that is intentionally going to be false, and then I'll trigger some side effect. I do need to actually import format because I want to, let's do like a print line. And I've got an extra brace there. No, I don't. So what have we got here? Unexpected new line, expected left curly brace. Oops. So actually this code just, it doesn't even, it seems like it doesn't even compile. That's not at all actually what I expected. If I put the brace where it's supposed to be, it will now compile. Great. But if I put it on the next line, let's try this again. It won't even format. It's just a syntax error. So honestly, I don't understand why they have this item in effective Go, because it seems like it's not even possible to compile code like this. So the compiler is going to enforce it, which I think is that to me is the ideal, where I don't even have to think about it. Mandatory braces encourage writing simple if statements on multiple lines. Sure. I know that some languages like Python do have, some languages do allow you like to write a ternary thing. Like in Python, it would be like x equals 3 if y else 2. And I think that type of like single line if statement syntax can be useful in some cases. Sir Johnston says, is that an actual compilation error, or is that just a linter error? What if you press run instead of format? Welcome back. Let's try. So if I press run on this, it just says syntax error, unexpected new line, expecting left curly brace after if clause. Maybe we should I wonder if we can just make a pull request to the effective Go guidelines to just remove this whole thing, because it seems like the compiler's already taking care of it for us. So I think it is an actual compilation error, but maybe there's some way to, I don't know if there's some flag that you could use to still compile, to just skip it and still compile, maybe. Okay. Yeah. So we've got this pattern everywhere in the cockroach code. What we do is we assign a new variable, usually an error, and then we check whether it's nil, and that will enter us into the like bail out block if statement. I think that this is a nice little pattern to squeeze both of these things onto a single line. Another thing is you don't write else's in Go unless you have to. So because this has a return statement, you would you would write this code using thing just right in the function. You don't put it inside of an else block. I think that that's a pretty reasonable rule. To me, it's very different from the way I usually think of writing a more functionally type language like Rust or Scala, where you would almost always use the else block, and potentially not even use the return keyword. So they've got another example of this where we're bailing out on this line and then also on this line. And so neither of those ifs have an else. And you can essentially have as many of those checks as you need to in your code. This thing is interesting. I haven't actually totally understood the rules for this. It's a little weird. But what you'll notice, this colon equals is normally used to declare new variable names. But if we look on line 5, error is actually already a variable name, yet we're still allowed to use it in a colon equals. So as an example, I think, what if we do like a colon equals 3 and then a colon equals 2? Is it going to yell at us? Yes, it is going to yell at us. So what it says here on line 5, it says we have no new variables on the left side of the colon equals. So the rule is actually that we need to declare, as long as we add at least one new variable, I think it's okay. So if we just do this, I think it's fine. Okay, it's still mad because we're not using the variables. Or it says Rust uses a ton of early returns. There is even an operator for it, which is the question mark operator. That's a good point. Yeah. Yeah, I guess maybe I'm thinking more of like an even more functionally language like Scala or like a Scala type thing, even though, you can kind of do anything in Scala. Yeah, so the rule, I guess, for this colon equals is that you need to have at least one new variable on the left side. Oh, that's interesting. So you're actually, when you're doing this, you're reassigning the variable. You're not declaring a new variable and shadowing it. That could be important if you have like a pointer to it. I find this a little bit confusing. Oh, here's the rules. So you have to have the same scope. Oh, if you can actually make a new variable in a new scope. So what can I do? Like, I think it's saying that I can do a new variable named A in my inner scope. Yep. it's mad at me because I'm not using these variables, but I think otherwise, like the declarations are valid. This unusual property is pure pragmatism, making it easy to use a single error value, for example, in a long if-else chain. Yeah, I think I think it is a very pragmatic solution. I like, I don't know, it's not overthought. It's pretty simple. I can see myself accidentally shooting my foot with this, but maybe not that much. So Janssen says, "You identifier hiding." Or at least I'm assuming that's what happens. That the outer A is hidden by the inner A. Yeah, I would call that. Yeah, it is exactly what's going on. I believe I would use the term like shadowing for this. Um, and I used to be extremely anti-shadowing, but I think it can be useful in some cases. Um, the place where I actually like shadowing would be like if you have like something that's like if you have two variables that if you want to intentionally prevent someone from referring to the outer variable, you could write something like a let's see, I'm trying to think of like a non-contrived example. It would be normally something like if you have like maybe an input and then you parse the input into another type, I might just use the same variable name for it because I know that I don't need to ever refer to the original input type. But I also see how you could accidentally do something really weird. Like, could I assign a new variable named format? I feel like I can. Yep, right. So I made a new variable named format, and now um, and now I can't call format.println because I've accidentally uh, rebound what format is. So Janssen says the input parsing example doesn't work though, right? Because it needs to be in a smaller scope. Yeah, that's a good point. So you might need to yeah, you could add another scope, but that would look kind of dumb. So yeah, good point. In yeah, I guess some languages will let you just um, some languages will let you do something like this, which is declare a completely new variable in pretty much the same scope that uses that could be, for example, a totally different type. We cannot do that in Golang unless we introduce the new scope. I don't totally, yeah. I mean, I don't know. I mean, every language has its own rules about variable shadowing. I don't know that there is one like perfect solution. I want a language that never lets me trick myself, but still lets me do what I want. Probably not even possible. So let's see. Yeah, we've got a very C style for loop here, but you can also throw in key values. And we've got underscore as a blank identifier to intentionally discard a value. I think that that's a great thing. You see that in a lot of newer languages. Does JavaScript have a way to discard values yet? I think the JavaScript that I learned in like 2015 is extremely um, out of date, and there's so many new features in JavaScript now. I'm not up to date at all. void in JavaScript. Interesting. I don't know about that. So when you're looping over a string, range will break it into Unicode code points. And they call these in Golang runes. Oh my. Wow. I want to see what. Oh yeah, okay. So this is gonna tell us what we want to do. So in JavaScript, void and then a function is undefined. Oh, interesting. So this thing, which is a well, I don't know. This just says Japan, and then this is an invalid UTF encoded byte, and then this is like the character for language. So it'll decode each character, and then our broken character, and then finally the last one. I'm more curious about like a script language, but I don't really speak any script languages, so I wouldn't be able to understand. Anyways. Go has no comma operator, and plus plus and minus minus are statements, not expressions. Oh yeah, I remember in C. I mean, A equals B plus plus versus A equals plus plus B. These would do different things. Like, so for this first one, it gives you the value, I think, after incrementing. For this one, it gives you the value of B and then it increments B. Source says, Go lets your strings contain invalid UTF-8, or is that just an undefined character? I believe that is invalid UTF-8. I think so. Well, why don't we just try making a string that's like definitely invalid UTF-8 and see if Go will let us compile. I'm pretty sure if we just do like a 0 byte, that would definitely be invalid, right? So I guess the question is, will this code like run? I think it will. Oh, I need a colon equals. And it's probably going to be mad that I'm not. So let's print it. So Janssen, what also is in JavaScript? Okay, so yeah, I think we can put invalid UTF-8 in our strings if we would like to. So you could use a string to hold binary data, for example. So I guess what they're saying is you're responsible for the integrity of your UTF-8 strings. So plus plus pre and post increment in JavaScript. Yeah, that thing always confused me. So what they're saying in Golang, plus plus and minus minus don't actually return a value. They only have the side effect of modifying your variable, which is cool. Wow, this is a pretty gnarly for loop. Initialize two variables. I actually don't understand what this comma is doing. Yeah, does anyone understand what's going on with this comma? I can see we've got the three. No, we've got three two semicolons separating like three clauses. Oh, of course. Yeah. Yeah. I is initialized to 0 and j is to length minus 1. Yeah. Definitely. Definitely. Something that we mentioned maybe last time or a couple streams ago, Go's switch is actually a little bit more like an if else chain because the condition of every case is completely independent. So, and you can just put any arbitrary logic in your case. I think it's a very simple way to deal with a switch statement. Um, they do have fall throughs, but it seems like we don't really use those at Cockroach, and maybe it's kind of recommended not to use fall throughs. Instead, if you want to do a fall through, how about just doing a multiple cases with commas? I think that would be a better solution in a lot of cases. And so we can also break out of a switch. We can break out also with labels. So how do we do that? I haven't actually. So break space loop. Oh, wow. So this, you can just put a label on your Go code? Is this, can I really just copy this loop colon thing into, is this part of valid Go? Let's see. Okay, so this code is not independent. So I guess we could just make a infinite loop here. And then we could type break loop. Oh, wow. So yeah, looks like we've got, yeah, we can just put a nice little label on our loop. I don't know that I've seen that type of thing around. Personally, I don't know. I'm not used to using breaking out to a particular level of the code. Here's a comparison routine that uses two switch statements. So there's one switch inside of a for loop to compare byte slices, where we're just iterating over every pair of bytes. And then otherwise, we'll compare the lengths of the two strings. Sort of says most C style languages have it. JavaScript has it. Rust has it, but your labels need to start with the apostrophe character. Yeah. So, okay, now we got a type switch and Go. This is also sort of just a control structures review in addition to a best practices review, I guess. Right. So, we get the type of a particular variable and switch on that, which is a special kind of switch statement. They're saying it's an unusual feature that functions and methods can return multiple values. I guess that's pretty true. But in a lot of languages, you can return at least tuples. At least definitely in Scala, Rust, JavaScript, I think even Python, and I actually don't think that's unusual. I would be I'm open to feedback, but I actually think it's a lot of languages can return either multiple values or tuples. And in a language like JavaScript, I think it's actually pretty expected that you may return like an error value as well as a value for if your function succeeds. But either way, I think it's a great feature. Right. And so in a language like C, you have to figure out some way to return errors. Sorry, you're saying the syntax is perhaps interesting. Yeah. But yeah, certainly I want to say, well, I think a lot of languages have some kind of like syntax sugar to allow you to return multiple values as opposed to wrapping in a tuple. But yeah, I think, yeah, maybe the syntax in Go, maybe it's a little bit more like built into the language. So in C, a write error is signaled by a negative count, and then you store the error code somewhere. Whereas in Go, for example, the function returns both the number of bytes written and whether there was an error, which is a really big improvement on the style from C. So I think that's great. What are they doing here? A simple-minded function to grab a number from a position in a byte slice. We're going to loop over the slice till we hit something that's a digit. Then we're going to leave I as the current value. Keep looping. Oh, I see. We're like decoding a base 10 number from the slice. Oh, that's fun. Named result parameters. This, I think, I haven't seen this. I haven't seen this in another language. Does anyone know a language that has named result parameters? So in this case, we have two ints that we're returning, and we give each one a name right in the function declaration. I think that is amazing, and I hope that future programming languages will all have this ability to name my return value or values right in the function definition. So let's look at this io.readFull using this. Sora says it's basically just returning an implicitly created struct. I guess so. Something like that. Sir Janssen says C# has that, but it's not really a feature of the function. It's just named tuples. Yeah, well, I think for me, the whole point is like you can do it without the boilerplate in Go, and it results in syntax that I think is really clean. Let's see how they do this. So I think what happens, as with any variable in Go, is that air is initialized to nil and then n is initialized to 0. So immediately in this for loop, air is already nil. So we can just jump right into the for loop. And n has started out as 0, so we can just start accumulating stuff onto it. And then when we do return, it just returns n and air automatically. I think this is nice looking. Suiku asks, are named returns actually used though in open source projects? That is a good question. Is there a way that we could search for that? I don't know how we would search with like a grep command or something, because we'd have to do like a pretty detailed match. It's definitely possible, but we would need to like somehow search for this kind of pattern. We might be able to search for a string like that, maybe. Let's go on GitHub and search in CockroachDB for this type of pattern. Where's the search button? I think I'm in the like, yeah, there we go. So I'm going to just search for an error in this repository. Ooh. I forgot the GitHub search seems to be like it's not an exact code search, but I could do it in my terminal. So I'll go to the cockroach directory here. Right. So this is the open source CockroachDB code. And then maybe I can just do a little searchy search for just this particular pattern. Ooh. I need to somehow escape the regex. -f is the argument that I want here, I think. That it thinks I'm trying to write a regex. So, Swiku, I don't know if you're still tuned in, but I can say that named returns are actually used in at least one open source project. Now that I'm looking actually through the vendor directory, it definitely looks like a decent number of open source projects do use this pattern. And actually it's even used in the Golang Golang's own code. So that's a good question, but it looks like named returns. I mean, there's like probably a couple thousand of those. So yeah, looks like we do use those. But thanks for asking that question. That was good practice for like, how do I search through code to find a particular pattern? Oh, defer. Goes defer statement schedules a function call. Yeah, I love defer. I think it's fun. It's like finally in Java. Swiku says that check, it's only looking for positive. You don't see how many times it returns unnamed methods. Yeah, so okay, that's a good point. So what if we start? I forget. I don't even remember how to do grep. Is it this thing? What I wanted to do was paste it into like word count. So what if we did to see how many times we have unnamed errors? Could we search for like this string? No, that's not the right thing. We need actually just the type error. So, ooh, Sora says, I think RG has -c for counting. That's exactly what I wanted to do. It does have that, but I want a total. Dash C, press. We have dash dash count dash matches. There has to be. I'm gonna probably Google this. I, I think I think it's like a. There's got to be something on Stack or Overflow, which is like rip grep count total or something. Okay, so they're saying to pipe to WC-L. That seems like a pretty normal thing. Yeah, so let's just pipe it into WC-L. So this is a search for how many functions return a single error that is not named. And then this is the search for how many times we return an error that has the name error. So, Sweeku, we got some data for you. This is 4,000 named and 17,000 unnamed. So it appears that in open source code, my first guess is that we name the return values about 20% of the time. I think there's a lot of exceptions. For example, we could name it E. That's happened 4 out of 20,000 times. Fine. But there's probably other like syntax patterns that I'm missing. I don't know if this is even legal to just have extra parentheses around error. Appears that that might not be legal. Suiko says, so it is not strongly enforced. Yeah, definitely. I don't think it's presented at all as a required thing. I think it's just like you can do it. So it does seem like more often than not, you do not name your return values. Ooh, comma space error. Right. So that's like anything that has an error versus you could also give it a name like this. So in this case, 7,000 out of 21,000 cases used a named return. So that's actually comforting because it's pretty consistent with this other number of 4,000 out of 7 or compared to 17,000. So yeah, it looks like we're kind of floating around like a fifth of the time or a fourth of the time we are naming our return value. Canonical examples for defer are unlocking a mutex or closing a file. I feel like we could have an entire stream about just defer and doing weird things with defer. Whoa. I don't know if I would write this code. Oh man. Right. So it executes backwards. So this will print 43210. I feel like you could do this is probably not for performance reasons a good idea, but you could do some fun stuff with this. So we've got a trace. And I really like this this defer un of trace where we perform both the effect and then kick off the defer in a single line of code. I think that's a good way to help programmers avoid forgetting to do the defer part. And we definitely use this pattern a lot at Cockroach. All right. Data. Golang has new and make, right? I think that seems different than many other languages. Does C have? C only has. Well, does C have any kind of allocation primitive, or is it you just like malloc? So new allocates memory and then zeros the memory, whereas make allocates memory and initializes the memory. Sir Johnston says, in C, you also have calloc, which gives you a zeroed buffer. Does malloc just give you uninitialized memory? I don't know C, as you can probably tell. So they suggest arranging your data structures so that the zero value can be used without further initialization. So you can create one with new and then start working. Sir Johnston says malloc gives you uninitialized memory, but Windows might zero it anyways. Okay. So the zero value for buffer is an empty buffer. That's nice. It's actually interesting that mutex is also initialized as an unlocked mutex. I guess that's because I think it's like Golang. It's like a Golang native mutex rather than using an operating system mutex that would require like a syscall to initialize it. So it's just kind of zero value. And actually, I really like this philosophy because we're initializing to initialize our synced buffer, we don't have to do anything because both mutex and buffer can be initialized and ready to use with zero values. That's fun. Source says, as far as I know, memory isn't technically uninitialized, but it is initialized with an undefined value. I think it's uninitialized memory does not have to exist until it's initialized. Oh, interesting. That is a complex distinction. I definitely know that the Rust model around initialized and uninitialized memory has actually been evolving a lot over the past couple of years after they found that the original modeling of it was unsafe. So I know that this whole area is super complex. All right, constructors and composite literals. So so if your zero value doesn't work, then you might need a constructor. So why do we need that for this file thing? Well, I guess the file needs a name. And we also need a non-zero, we need like a valid file descriptor, I think, is what this FD probably stands for. A composite literal. So rather than making a new file and assigning each value, we're just putting the values right into the struct, which seems good. In C, unlike in C, it's okay to return the address of a local variable. I feel like in some cases, Go has gotten mad at me for trying to return the address of a variable. I'm not totally sure when that happens, though. Talking about whether memory might be physically allocated until the process accesses it, my understanding was that in some operating systems have the latitude, like I want to say on some Linux operating systems, I can say, okay, allocate like 4,000 terabytes of memory, and the operating system will say, sure, I allocated it, but not actually physically allocate the memory until I try to write to it or read from it. So my understanding was that that's actually tough if you're trying to detect out of memory situations, because you could have a situation where the operating system reports that your memory has been successfully allocated, even though there might not even be physical memory enough to represent that allocation. So you'll eventually get an out of memory error when you try and touch the memory. And I think that that's tough, because it's like essentially any point in your application where you access allocated memory would need to guard against this possibility of the memory not existing, I think. So back to this thing. The storage associated with the variable survives. Yeah, right. Because Go is garbage collected, whereas C is manual memory management. Totally makes sense. The values of a composite literal are laid out in order and must all be present. One thing I didn't notice here, right? So we're not actually even specifying like the name of, like I have no idea what this 0 is doing looking at it. If I look at the previous code, I see that it is setting a NE pipe, which not sure what that is. But yeah, just looking here, you don't actually have to say what field the 0 is filling out. But you can. So maybe this might be useful for clarity in some cases. But in other cases, maybe you don't need to, because like it's obvious what FD is here. Oh, Sora, you tried to paste a link, but like Twitch or something it doesn't let links through. Yeah, it's kind of annoying. I think it thinks that you're trying to spam the stream. Or maybe does the chat show up on Twitch but just not on this like Restream chat app that I have on the screen? So we're also using composite literals for arrays, slices, and maps. Yeah, the whatever, either like Twitch or Restream really does not like links. You could just maybe you could just like base 64 encode the link. Oh, how did you do that? Oh, fascinating. The cockroach stream only has this anti-linking technology. Good to know. Oh yeah, this thing may be uninit. Fascinating rabbit hole. I have not taken the time to learn about this in detail. Don't do this though. I saw someone posted on the Rust forum. They literally actually they had this exact snippet of code, and they were like, "Why doesn't my code work?" And it's because you're not allowed to do that, I guess. Unsafe in Rust, a terrifying prospect, a terrifying but fun prospect. So allocating with make is for slices, maps, and channels, and it returns an initialized value. And it's because these data structures are all secretly pointers under the hood. Or maybe like rich pointers. Oh, sorry, you're saying the third paragraph. 1, 2, 3. Uninitialized memory does not have a fixed value. Reading the same uninitialized byte multiple times can give different results. Terrifying. Absolutely terrifying. Hate that. So yeah, we can use this to make little slices. And yeah, arrays and channels. Let's see how far we are on this thing, because it is pretty long. I don't think we're going to get through the entire thing today. My goal, let's see if we can finish up data for today. So far, we've gotten down to slices, and we got to cover like a few more things. So yeah, just thinking on kind of like stream meta stuff. What I'm thinking right now is that I'd like to bring some more people onto this stream to kind of chat about various topics. I'm hoping to wrangle somebody from Cockroach to chat about some Golang stuff with me. I think that's going to be a good way to, I mean, it's always helpful to learn from somebody with a few more years of experience. So my next mission is going to be to convince somebody to help me learn about some more intermediate to advanced Golang topics. And there's a lot of talented Go engineers at Cockroach, so I think I'm going to be able to convince someone. But yeah, definitely curious for anyone who's tuned in, what kind of stuff you'd want to learn about with relation to Golang or otherwise. My sense is that, frankly, this effective Go stream is probably not the most engaging content. That's okay. I mean, I think it requires experimentation to narrow in on what kind of stuff people enjoy most. And, it's okay to have different types of content that appeal to different kinds of people. I can actually mention a couple of the stream ideas that I have for the future. I wrote them down. Did I though? I wrote them down, but now I can't find them. I put them in like a Google Doc that's hidden. Let's see. Okay, I found them. Here's my stream ideas. Let me know which of these ideas are good or bad. Common Golang mistakes. Golang best practices at Cockroach Labs. Garbage collection in Go. Understanding Go routines. What makes Golang unique? Linting in Golang. Get ready for Golang generics. Concurrency primitives in Golang. And Golang standard library secrets. That's what I've got so far. Although I'll keep brainstorming. Sora suggests maybe we can loop in large data bank. I think that would be great. Jordan is definitely an excellent role model for me, both in terms of streaming and engineering. So I think it'd be fun to either bring him onto this stream or potentially just interview him on his own stream, because otherwise he'd be like streaming for like 8 hours on a Friday. I think he's just like developed superhuman streaming abilities though at this point. So yeah, short synopsis, hoping to have some people on next stream. And the next stream is going to be in 2 weeks from now, not 1 week because of a holiday 1 week from now. So yeah, this is kind of explaining slices. Cool. I think we learned about that previously. And you can have multiple slices referring to the same array. And you can change the length of a slice as long as it still fits within the limits of the underlying array. So assign it to a slice of itself, okay? So if the data exceeds the capacity, the slice is reallocated. Would that leave the original data in place, I'm guessing? Let's see. So what have we got here? We've got two slices, one called slice, the other called data. They're both of byte slice types, and we're also returning a byte slice. Great. First, measure the length of slice. Then, if the length of the data would exceed the capacity, then we need to do a new allocation. We call make, which we just learned about, to create a new slice that is double the new space needed. Great. Copy the new slice, or copy the old data into the new slice, and looks like we're good to go. And then whether or not we reallocated, we change like the bounds of the slice, copy data into the slice, and then return it. One thing that I love about Golang is how insanely readable the standard library is. I think that's amazing. And if you saw this same like code in the Java standard library, it would look like alien language basically. But I just love how Golang is written in simple and understandable Golang. I don't know if this is the actual code from the Go standard library. Let's take a look. So function append. Let's pull up the code. Ooh, ooh, interesting. So this one is probably a little bit more complex because it takes a whole like variadic array of things to put in here. But yeah, overall seems. So this is a built-in function. So I guess this thing is like built into the compiler. So this is not production code probably, but still easy to read. Two-dimensional slices. An array of arrays or slice of slices. Yeah, I've heard for like performance reasons, in some languages you don't want to do this because the outer one would be just like an array of pointers. So you don't get the whole thing contiguous in memory. Sora has evolved beyond garbage collection. Yeah, I think Golang does have like pretty smart escape analysis. I don't know if I mentioned this as a stream idea, but I think understanding the I think understanding the Go garbage collector and like its interesting tricks would be pretty fun. But I don't know. So I'm gonna say if you're doing this slice of slices thing and you need really high performance, you should consider just using a single slice. And that's I think that advice applies to pretty much any programming language where you would have that layer of indirection. Ooh, interesting. This is a fascinating trick they're doing. So they're actually saying allocate a single array and then point each individual slice into it. Sure, why not? That's a little, yeah. So that way you still get contiguous memory. And so this thing, I mean, each time we call slice, we're potentially allocating it into a different piece of memory. But on this other and better system, we're allocating one single big chunk of memory by multiplying the x size and the y size to get the total number of elements. And then we're actually going to save each slice as a little view into that large memory block. I like that a lot. I think that's good, both because we only need to perform allocation once, but also because the final data is all going to be beautifully contiguous in memory, and you'll get great performance from that. So maps, you got keys, you got values, sure. And we've got this nice composite literal syntax. That is, I definitely do think that a language should have built-in syntax for map literals. It's just so much nicer to be able to declare the map inline like you can do in JavaScript, Python, Ruby, all those nice scripting languages. So I really appreciate having that around. Yes. Yes. Rust does not have that. And you have to import this like third party. Yeah, you have to like in Rust, you have to do this third party macro if to get map literals. So you have to do this little thing at the top of your file, and then once you get the literals, they well, it's actually not that great even because this thing is a macro, so it's harder for your IDE to analyze it. It also adds a little bit of code bloat. Java also doesn't have map literals. Definitely. I feel like almost every project I'm like, oh, I need map literals. I'm just gonna add maplet anyways because I just like I don't like having to like declare the map and then just push things into it. I like having the literals. Oh yeah. An attempt to fetch a map value with a key that is not present in the map will return the 0 value for the type of the entries in the map. I feel like that probably tricks a lot of people. I don't think that I've been tricked by that myself, but I'm a lot more used to that situation, like returning an error. Sora says I avoid using hash maps in Rust. Yeah, that's reasonable. I probably overuse hash map just because it's so easy and it's just like I just don't want to have to think more about like what type of map to do. But especially for like game development stuff, I think hash map is often as you know a suboptimal choice for performance. Sometimes you need to distinguish a missing entry from a 0 value. That seems very useful. Yeah, so what it does is it returns an OK value, which is like, did I find this value in the map? I don't know. I'm not feeling this. No option in Golang. Yeah, no algebraic data types on this stream. No, sir. Okay, so let's see. Oh, yeah, and then we can also just ignore the actual value. Fun. To test if something's in the map. So where am I? We're at printing now. Okay. Yeah. I feel like format strings that whole thing to understand fully can take a long time just because there's so much power and flexibility that the format strings offer you. I do like this percent plus v syntax, which will print out your struct with all of the names. It just makes it really easy to do quick print debugging. And you can also do this percent hash v, which will give you something that you can just literally copy paste as Go code. I think that's awesome. Note the ampersands, right? Oh, okay. So this is like because it's a pointer, I guess. Hey, generics are coming soon. Coming anytime. I know some people at Cockroach are pretty excited about generics. So I think I'll try and get somebody on the stream to like pitch Go generics and explain a little bit about maybe how they're similar or different to generics in other languages and what it's going to what they're going to enable. I mean, I love algebraic data types in every language, but unsafe. Unsafe is interesting. Go does have a concept of unsafe, but it's confusing because it means something completely different than unsafe in Rust. And I don't totally remember exactly how they overlap with each other. Yeah, definitely could stand to learn about some unsafe. So let's see. What we're looking at format strings. Yeah, sure. What are we supposed to be learning about here? I'm confused. %t prints the type. Oh yeah. So we're talking about controlling the default format, which is where we define a method called string that returns a type string. Yeah, my feeling is that in Go, unsafe generally means more like what a more an intuitive definition of unsafe, whereas unsafe in Rust has an extremely specific meaning related to this can cause undefined behavior. So we defined a custom printing type. Oh, yikes. Don't construct a string method by calling sprintf in a way that will recur into your string method indefinitely. Sure. So it's saying that you just need to not cause an infinite loop when you're defining your custom string function. That seems like a good idea. Oops. Right. And I think they're doing that. This %s probably calls this string function and it'll just go forever. So we fix that by explicitly converting this my string into a string. Yeah, don't cause infinite loops. That's what we learned from effective Go today. Actually, I don't know. I think this error I probably could have accidentally done that. Passing a print routine's arguments directly to another routine. Interesting. Yeah, I've definitely accidentally caused an infinite loop when trying to do like displaying a type or something like that. Ooh, yeah. Oh, so now they're actually talking about a pen, which we were just discussing earlier, and we actually have over here on the left side of the screen. So this takes in a list of elements, and T is a placeholder for a given type. Seems pretty generic to me. Seems pretty generic. Oh, interesting. So that's why append is built in. It's because it has compiler support. So yeah, now that I'm thinking about it, all of these different like copy, delete, length, these are all generic. So where are you seeing this uint of 0? I think I must have missed something. Are they XORing a 0? Let's see. Where do they XOR a 0? I don't think I missed it. Is this in the code over here, or is it in the effective Go? Oh, this thing. Well, would this be an XOR, or is this like I think that must mean a bitwise complement because it's a unary operator. So my interpretation is that this is the value 0. They hit it with this caret sign, and it flips from being all zeros to all ones. Something like that. It's a bitwise not. Yeah, okay. Because if you XORed something with 0, what you would just get the same thing. It just wouldn't do anything. So how do we append slices to slices? So I think we are now at the next section, which is initialization. So I'm gonna call it a stream for today. But coming back in 2 weeks on June 25th. Wow, that seems so far away. It's already like we're already like way into summer in the northern hemisphere over here. But yeah, coming back on June 25th and planning to have a guest on the stream, probably going to talk about some intermediate or advanced Golang. Yeah, so enjoy your Junes and see you in 2 weeks. Thanks for tuning in.